A couple of months ago, astronomers caught sight of something faint and almost forgettable. Just a smudge of light sliding slowly across the night sky. At first glance, it looked like any other comet, the kind that comes and goes without much fanfare. But then the calculations came in. And with them, a revelation. This wasn't a comet from our solar system at all. This was something much rarer. A visitor from another star. Traveler crossing the endless void to swing past our sun before disappearing forever. They called it Comet 3I Atlas. Back then, we knew almost nothing. Just that it was moving incredibly fast, and its path wasn't looping back. It was on a one-way journey. But since that first discovery, everything has changed. The comet has brightened, its tail has stretched into something spectacular, and the James Webb Space Telescope has pointed its eye directly at it. And what Webb saw has shocked even the most experienced scientists. The chemistry is so bizarre, so upside down, that it's forcing astronomers to rethink what comets even are. So today, we're diving deep. Where this comet came from, what makes it so alien, and why some astronomers say it might be the most intriguing interstellar visitor humanity has ever seen. But before we get into Webb's shocking discoveries, let's rewind for a moment. Because if you're hearing about 3I Atlas for the very first time, you might be wondering, what's the big deal about this comet? Why is everyone suddenly talking about it? It all started in early July 2025. At the top of a mountain in Chile, the Atlas Survey Telescope was quietly scanning the sky, looking for moving dots, faint intruders among the stars. That's when astronomers noticed something unusual. A fuzzy little point of light with just the slightest hint of a tail. Nothing about it seemed extraordinary at first. We've seen thousands of comets before, but when they ran the numbers, the orbit didn't make sense. Normal comets in our solar system follow stretched-out ellipses, swinging in close to the sun and then drifting back into the cold. They're bound, trapped by the sun's gravity. This object wasn't bound. Its orbit wasn't elliptical at all. It was hyperbolic, a trajectory that meant it wasn't coming back. It wasn't from here. It was just passing through. In plain English, 3I Atlas is an interstellar comet, a visitor from another star system. Now let's pause there for a second, because when I say this is rare, I mean unbelievably rare. Humanity has cataloged millions of comets and asteroids, and yet, before 3I Atlas, we had only ever confirmed 2 interstellar objects. 2. In all of history. The first was Oumuamua, discovered in 2017, a strange, cigar-shaped rock that zipped through without a comet's tail and left scientists arguing for years about what it even was. Some thought it was an asteroid. Some thought it was a comet that just didn't behave like one. And some even whispered, maybe it was alien. The second was Borisov, spotted in 2019. Unlike Oumuamua, Borisov looked and acted like a comet right from the start. Glowing coma, long tail, the works. Its chemistry wasn't too different from what we see in our own backyard. And now, 3I Atlas, the third member of this exclusive club. Think about that. 3 objects, out of billions we've cataloged. That's how rare these interstellar messengers are. And this one is already breaking rules. After the initial discovery, astronomers kept their eyes locked on 3I Atlas. At first, it was just a faint blur, but even from a staggering distance, more than 3 times farther from the sun than Earth, it was already waking up. Normally, comets that far away are quiet, frozen, inert. But 3I Atlas was already showing a coma, that glowing cloud of gas and dust that forms when sunlight starts heating its icy surface. That early activity was a huge red flag. If a comet is outgassing this much at such a distance, it means something unusual is happening beneath the surface. Something volatile, something alien, and astronomers knew, if this is what it looks like far away, then as it moves closer to the sun, things are going to get very interesting. Months later, the changes have been dramatic. The once faint smudge has grown into a dazzling object. Its coma has brightened. Its tail has stretched out, trailing behind it like a cosmic banner. But the real surprise? Observers started noticing hints of a green glow. Now, green comets aren't unheard of. In fact, you may have seen headlines before about the green comet passing Earth. That glow usually comes from molecules like diatomic carbon or cyanogen, which fluoresce under sunlight. But for Atlas to show this glow so far from the sun, that's unusual. Suggests either it's packed with an unusually large amount of these molecules, or it's releasing them much earlier than expected. And that's not the only strange thing. Atlas isn't shedding material evenly. Its activity is lopsided, much stronger on the sun-facing side. Sure, that sounds logical since the sun is the heat source. But the asymmetry here is sharper than usual. It hints at a nucleus that's uneven. Maybe one part is richer in ices, or fractured in a way that vents gas more easily. Put simply, this comet is not behaving like a normal comet. Now here's where things take a dramatic turn. Ground-based telescopes can show us what a comet looks like, but they can't always tell us what it's made of. That's where the James Webb Space Telescope comes in. In August 2025, JWST turned its golden mirrors toward 3I Atlas and used its near-infrared spectrograph to analyze the light. Here's the idea. When sunlight bounces off a comet and passes through its coma, it carries hidden fingerprints of the molecules there. Webb breaks that light into a spectrum, a rainbow of wavelengths. And inside that rainbow, every molecule leaves a signature. Water, carbon dioxide, methane, you name it. It's like scanning a cosmic barcode. And with Webb's precision, scientists don't need to fly out and sample the comet directly. They can read its chemistry from millions of miles away, so what did Webb see? Scientists expected the usual, mostly water vapor, maybe some carbon monoxide and carbon dioxide. That's the standard recipe for comets in our solar system. But 3I Atlas didn't follow the recipe. Not even close. Instead of water dominating the mix, 3I Atlas was spewing out carbon dioxide. Not just a little, a lot. The ratio of carbon dioxide to water vapor? Roughly 8-to-1. To put that in perspective, most comets in our solar system have way more water than carbon dioxide. This comet flipped that ratio completely upside down. Why does that matter? Because it tells us something about the conditions where this comet formed. There are two main theories. It formed in a super cold region of its home system, a place where carbon dioxide could freeze solid and pile up, while water ice stayed buried deeper. Its surface is sealed. Maybe a crust formed that traps water, letting only carbon dioxide vent for now. Either way, it's not just strange. It's alien. Every comet in our solar system is a time capsule from our own past. But this one, it's a frozen relic of another star's nursery. A message in a bottle from a completely different place in the galaxy. The surprises didn't stop with chemistry. Astronomers also studied how light scatters off the dust around 3I Atlas, using a technique called polarimetry. Think of it this way. When light bounces off particles, it changes slightly. By measuring those changes, scientists can figure out the size, shape, and texture of the dust. It's like a handshake. A handshake tells you more than just who someone is. It tells you if their grip is firm, soft, rough, strong. Polarimetry is the comet's handshake. And Atlas's handshake was unlike anything we've ever seen. The comet showed an extreme negative polarization branch, stronger than any comet observed before. Translation? Its dust was scattering light in a way that's totally alien. That means one of two things. Either the dust particles are shaped in unusual ways, or they're made of materials not common in our solar system. Some think the grains might be darker, coated in complex carbon compounds. Others think the dust might be clumping in unexpected structures. Whatever the cause, it's clear. Even the dust from this comet isn't playing by the rules. So let's take a step back. We've now had 3 confirmed interstellar visitors. Oumuamua, the mysterious rock that had no tail and sped away with an unexplained push. Borisov, a more traditional comet behaving like the ones we know. And now 3I Atlas. A comet, yes, but with chemistry so alien it flips the script. 3 visitors. 3 completely different stories, and that's the point. These objects are showing us just how diverse the galaxy really is. If just 3 can be this wildly different, imagine what the 4th will look like. Or the 10th. Or the 100th. We're just scratching the surface of cosmic variety. Now, whenever something like this shows up, the same question always creeps into the conversation. Could it be alien? Oumuamua got that treatment. And sure enough, 3I Atlas has sparked the same whispers. Harvard astrophysicist Avi Loeb even proposed a scale for rating interstellar objects, from 0, definitely natural, to 10, definitely artificial. He gave 3I Atlas a 2 or 3, mostly because of its size and its unusually clean orbital path. But here's the thing, there's no actual evidence of alien technology here. No radio signals, no sharp engineered shapes, no signs of maneuvering, and honestly, the natural explanation is far more exciting. Because if one interstellar comet can look this different, that means there could be millions more, each carrying a different recipe from its home star system. Each one a frozen postcard from another world. That's not science fiction. That's the reality the data's giving us. Think about that for a second. 3 in total out of the billions of comets and asteroids we know. These things are once-in-a-generation discoveries. When astronomers crunched the numbers, they found 3I Atlas was moving at around 221,000 km/h, about 137,000 km/h. That's blisteringly fast. Its nucleus is estimated to be 0.5 to 2 km across. Small but potent core driving its spectacular coma and tail as it hurtles through space. To put its speed into perspective, that's quick enough to get from Earth to the Moon in under 2 hours. At that speed, it's clear this comet wasn't just wandering around our solar system. It was on a one-way pass-through, a visitor just saying hello before continuing on into deep space. At the time of discovery, it was still far out, more than 3 times farther from the Sun than Earth is. But even from that distance, it was already showing signs of activity. A faint coma of gas and dust was visible, a clue that sunlight was heating its icy surface and starting to release material. That early glimpse was enough to get scientists excited, because if it was already waking up at that distance, what would it look like when it got closer to the Sun? And that's where we left things in the last video. 3I Atlas was new, mysterious, and full of potential. We knew its closest pass to the Sun would be in late October 2025, and that in December, it would make its nearest approach to Earth, though still at a safe distance of about 170 million miles. There was no risk to us, but there was a huge opportunity. A chance to study something truly alien up close. Now, fast forward to today. Since that first discovery, astronomers around the world have been keeping their eyes on this comet. And the James Webb Space Telescope has just given us the clearest, most detailed look yet. And the results, they are not at all what scientists expected. Before we continue, let me show you something that honestly blew me away. This is the hover pen Interstellar from Novium. It's not just a pen. It actually floats, suspended in a magnetic field. No batteries or wires needed. The design is inspired by space itself, standing at a perfect 23.5 degree tilt, just like Earth's axis. It's made from aerospace-grade aluminum, refillable, and looks incredible spinning on its base. It even won a Time Award as one of the best inventions. And if you really want something out of this world, there's a version with an authentic meteorite shard, embedded in the tip, literally older than Earth itself. More than half of Novium's customers buy Hovens as gifts, and you can see why. The packaging alone makes it feel like a premium experience. It's the kind of thing that looks amazing on your desk, sparks conversations, and is perfect for someone who appreciates unique, high-end design. And if you prefer a fountain or roller ball, there's the Hover Pen Future, with interchangeable tips and a sharper 60-degree futuristic look. Right now, you can get 15% off for the next 48 hours and 10% after that. Just use my code FEXEL or click the link in the description. One of the first big updates came from the Gemini South Telescope in Chile. Late August, astronomers captured new images that showed the comet's coma had grown brighter, and the tail had stretched out. Noticeably, it wasn't just a fuzzy smudge anymore. You could actually see it taking on that classic comet look. That change alone told scientists a lot. It meant the comet was shedding more material as it warmed, releasing gas and dust at a much faster rate. In other words, it was coming alive. Then came something even more intriguing. Some observers started noticing hints of a greenish glow in the comet's coma. If you followed comets before, you know this isn't unheard of. Comets sometimes turn green when molecules like diatomic carbon or cyanogen get excited by sunlight and start fluorescing. But the possibility of Atlas glowing green so far from the sun got people talking. Could it be carrying an unusually large amount of these molecules? Or was it just starting to release them earlier than expected? Astronomers are still cautious about confirming the color, but even the suggestion adds to the sense that this comet isn't following the usual playbook. And here's another key point. The comet's activity isn't symmetrical. Observations show that it's shedding more material on the sun-facing side than the shadowed side. That may sound obvious since the sun is what's heating it, but the unevenness is sharper than normal. That hints at a nucleus that isn't uniform. Maybe part of it is more volatile rich, or maybe the structure itself causes gas to escape more easily in certain areas. Either way, it's giving scientists a front-row seat to how an alien comet behaves under solar heat. So the visuals have changed a lot since it was discovered. A brighter coma, a longer tail, a possible green glow, and asymmetric activity. But that's just what telescopes on the ground could see. The real breakthrough came when astronomers pointed the James Webb Space Telescope at 3I Atlas. Because while ground-based images show us how it looks, Webb can tell us what it's actually made of. And that's where the story takes a sharp turn. The James Webb Space Telescope wasn't designed just to look at galaxies billions of light-years away. It's also perfect for studying the small, icy visitors much closer to home. So when 3I Atlas came into view, astronomers knew Webb had to be part of the investigation. On August 6, 2025, JWST turned its powerful eye toward the comet, using its near-infrared spectrograph, or NI-SPEC for short. Now that might sound technical, but the idea is simple. A NIRPEC doesn't just snap pictures. Breaks the comet's light into its different wavelengths. A bit like how a prism spreads white light into a rainbow. And hidden in that rainbow are chemical fingerprints. Every molecule, water, carbon dioxide, methane, you name it, leaves a unique mark. So when Webb reads the light from a comet, it's basically scanning a barcode of everything that's evaporating off its surface. What's so powerful about this is that it works even from millions of miles away. We don't have to fly a spacecraft out there, scrape off some ice, and bring it back. JWST can tell us the recipe just by looking at the light. It's kind of like smelling food cooking from across the room. You may not see the ingredients, but your senses can pick out what's there. Webb does the same thing, but with a level of precision that no human nose could ever match. So, what did it see? Scientists expected to find the usual mix. Plenty of water vapor, maybe some carbon dioxide and carbon monoxide along with dust and ice grains. That's the standard signature for comets from our own solar system. But 3I Atlas wasn't about to play by the rules. The data that came back from Webb shocked even seasoned comet experts because this visitor from another star system turned out to be loaded with something we don't normally see in such abundance. When astronomers looked at the results from JWST, they immediately saw something they weren't expecting. Instead of water dominating the mix like it usually does with comets, 3I Atlas was blasting out carbon dioxide. Not just a little bit either. The ratio of carbon dioxide to water vapor was about 8.1. For comparison, most comets in our solar system have far more water than carbon dioxide. So, to put it simply, this comet's chemistry is upside down. That raises some interesting questions. Did 3I Atlas form in a region of its home system that was so cold carbon dioxide could freeze and pile up while water stayed locked away? Or is the surface of the comet somehow sealed, letting CO2 escape more easily while water remains trapped until it gets much closer to the sun? Both are possible, and either way, it means this comet carries a story about conditions in another star system that were very different from ours. Think about that for a second. Every comet we study from our own backyard tells us about the early days of the solar system, what the disk of gas and dust around the young sun looked like. But 3I Atlas isn't from here. Its frozen chemistry is a sample of another nursery, around another star shaped by different temperatures and different chemistry. Looking at it is like holding a rock from another planet, except this one's origin is even more distant and uncertain. And here's where the surprise gets bigger. Carbon dioxide isn't the only thing Webb spotted. Mixed in with the outgassing were water, carbon monoxide, a sulfur-bearing molecule called OCS, and plenty of dust and ice. So yes, water is there. It's just not the main player. It's like expecting a glass of mostly water and finding out it's mostly soda with just a splash of water mixed in. This discovery forces astronomers to think differently. If one comet from another star system already breaks the rules, how many other variations are out there drifting through interstellar space? How many different ways can planets and comets form around other suns? Each answer seems to point to a galaxy far more diverse than we ever imagined. Now, here's where things take another turn. Beyond chemistry and dust, astronomers tried something different with 3-eye Atlas. They didn't just look at what was in the coma, they studied how light bounced off it. This technique is called polarimetry, and while the word sounds technical, the idea is pretty straightforward. When light reflects or scatters off tiny particles, it changes in ways that can reveal the size, shape, and texture of those particles. Think of it like shaking someone's hand. The handshake tells you more than just who the person is. It gives you a sense of their grip, their strength, maybe even their mood.